Hello everyone. So this is a question from JEE Mains 2026 8th April Shift 2. So we have match list 1 with list 2. We have list 1 of electronic configuration of neutral atom where the principal quantum number is equal to 2, and list 2 is the first ionization energy in kilojoules per mole. Okay. So we have to talk about ionization energy or enthalpy. The chapters involved is periodic properties. So ionization enthalpy is the minimum amount of energy that is required to remove the most loosely bound electron. Okay, so I will write that down. Ionization energy is minimum energy required to remove the most loosely bound electron, or that is the outermost shell electron, or you can say the outermost shell electron from an isolated gaseous atom. Okay, so this will be the definition of ionization enthalpy, and this will be also known as ionization energy, or sometimes it is also called as first ionization energy, since we are removing the electron from gaseous atom. Okay, so with respect to diagram, let us say that we have this as the nucleus, and let's say we have an electron which is present. This is the electron at the outermost shell. So how much energy we are supposed to give to this guy so that it goes out? So that energy is known as the ionization energy or ionization enthalpy, or it is also known as the first ionization enthalpy. Okay, so what will be second ionization enthalpy after we have knocked this electron out from an atom, from a gaseous atom? So we will be left with a cation, right? So let's say this is the cation. How much energy will be required to knock an electron out from the cation? That will be known as the second ionization energy. Okay, so in this question they have told us about first ionization energy. So all of them are talking about the gaseous atom in their ground state. Okay, so the symbol of ionization energy is delta IH, where I stands for the number. For example, if it's a first ionization enthalpy, it will be delta 1H, right? And if you want to represent this with respect to a reaction, it will be represented as M. Let's say we have a gaseous atom, and obviously we have to give delta 1H so that we knock one electron out from this gaseous atom, which will result into a positive cation. So we will get a positive gaseous cation plus electron, right? Okay, and the units of ionization energy is kilojoules per mole. Okay, next we have to talk about the factors governing ionization energy. Factors governing ionization energy. The first important factor which is affects the ionization energy is nuclear charge. Nuclear charge is basically the number of protons in the nucleus, or you can say indirectly the power of the nucleus, right? So ionization energy increases with increase in nuclear charge. Very important. Increases with increase in nuclear charge. Okay, because with the increase in nuclear charge, electrons of the outer shell are more strongly held by the nucleus. Okay, so let's say this is our nucleus, and let's say we have our outermost electrons are here. So as the power of the nucleus or the nuclear charge increases, this guy will pull these electrons even more strongly towards itself. Why? Because the number of protons are increasing, so the power of the nucleus is increasing. Okay, and greater energy is required to knock this electron out from the atom, because this guy is pulling it with a more nuclear charge now. Okay, so therefore as ionization energy increases, ionization energy increases with increase in nuclear charge. Okay, in our question we have been given second period elements, if you can see, because they have mentioned that the value of N is equal to 2. Okay, so this is basically beryllium, this is boron, this is nitrogen, and this is neon. Okay, so we'll write them down separately. So in the question they have given us 1s2, 2s2, which is beryllium, 1s2, 2s2, 2p1, which is boron, 1s2, 2s2, 2p3, which is nitrogen, and one second, I will have some gap here. So 1s2, 2s2, 2p3 is nitrogen, and 1s2, 2s2, 2p6 is neon, right? So their atomic number is 4, so therefore the nuclear charge will also be equal to plus 4 because there are 4 protons in the nucleus. Here the atomic number is 5, so the nuclear charge will be plus 5. Here atomic number is 7, so the nuclear charge will be plus 7. Here the nuclear charge is 10, so the atomic number is 10, so nuclear charge will be plus 10, right? So therefore the ionization energy order should be beryllium, boron, nitrogen, neon, right? Because nuclear charge increases from left to right. Okay, but actually this is not the correct order. Okay, the actual order is boron, beryllium, nitrogen, neon. Okay, so this will be explained by the next factor. Okay, there are more factors which affect ionization energy. The second factor is known as the penetration effect of the electron. Penetration effect of the electron. So we know that electron of the s orbital has the maximum probability of being found near the nucleus, and this probability goes on decreasing in case of p, d, and f orbitals of the same shell, right? So we know that electrons of s orbital, so this guy has the maximum probability of being near the nucleus, and this goes on decreasing in the case of p, d, and f, right? So this is what is known as the penetrating effect. So we can say that s electron of any shell are more penetrating towards nucleus than p, that is they are more available near the nucleus. One second. So we can say that s electron of any shell are more penetrating towards nucleus than p. So therefore we can say that penetration effect decreases in the order of s, p, d, and f, right? Because s has the probability, an electron in the s orbital has more probability being found near the nucleus, so that's why it has more penetrating effect, right? And if penetration effect of electron is more, it will be closer to the nucleus and held firmly by the nucleus, isn't it? So therefore ionization energy will be high because it is spending more time near the nucleus. So therefore ionization energy is actually directly proportional to the penetration effect of electron. So therefore the ionization energy will be more to knock out a s electron, then a p electron, then a d electron, and then a f electron of the same shell. Remember, always we are comparing these guys from the same shell. This is the important point. When you use penetration effect, make sure that orbitals are from the same shell. Okay, so now you will understand why is there an anomaly in this order. Okay, so if we look at the configuration of boron, so boron's configuration is 1s2, 2s2, 2p1, and beryllium's configuration is 1s2, 2s2, right? So here we are knocking electron out from p orbital. Can you see? From p, and p has less penetration, so therefore it is easier to knock the electron out, so therefore it has less ionization energy compared to beryllium. In beryllium we have to knock electron out from s orbital, which has very high penetrating power, and therefore a very high value of ionization energy is required. So therefore the ionization energy of beryllium is more than boron, despite boron having more atomic number, or more charge on the nucleus. Okay, the therefore this is the order. Okay, and there is one more factor, which is the third factor, The third factor is electronic configuration. Okay, so if an atom contains exactly half filled or completely filled orbitals, okay, exactly half filled or completely filled orbitals, these type of arrangements, they provide extra stability, we know that. Okay, so therefore removal of electrons from such atoms will need more energy than expected. That's very obvious because we are disturbing a very stable system. A very good example is what is given in our question, that is nitrogen. So nitrogen's configuration is 1s2 2s2 2px1 2py1 and 2pz1, right? So it is exactly half filled. And neon is 1s2 2s2 2px2 2py2 2pz2, so it is a noble gas, right? So noble gases have the highest ionization energy in their respective periods. So therefore obviously neon, which is option D, will have the highest value, which is 1, and the ionization energy is 2080 kilojoules per mole. Okay, the next in value will be nitrogen because it is exactly half filled, which is in the option, it is C. So it will have the second highest value, that is the fourth value, that is 1402 kilojoules per mole. And next will be beryllium, right? Because in beryllium we have to remove electrons from 2s, so therefore more energy required, high penetrating effect or power of the s orbital. So it will have the third highest value of 899 kilojoules per mole, right? And so beryllium is basically A, and boron is B option in the question. And boron's configuration is 1s2 2s2 um, 2p1. So we have to remove one electron from 2p, which has less penetrating power, so therefore less energy required, so therefore it will be the least value out of the given options. So therefore it is 800 kilojoules per mole. Okay, so looking back at the options, A will be 2, B will be 3, C will be 4, and D will have the maximum, that is 1. Okay, so this will be the answer. Okay, thank you.